Good morning students, my name is Priyanka Jain. I hope you all are fine and safe. Now our today's topic is combination of errors. Combination of errors. For example, mass density is obtained by deriving mass by the volume of the substance. If we have errors in the measurement of mass and of the sizes or dimensions, we must know that the error will be in the density of the substance. To make such estimates, we should learn how errors combine in various mathematical operations. For this, our first point is error of a sum or a difference. So error of a sum or a difference, hence the rule says when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantity. Let us take, if z is equals to a plus b, then maximum possible error in z will be del z is equals to del a plus del b. Now, if we take z is equals to a minus b, if we take a difference in error, then maximum possible error in z will be del z is equals to del a plus del b. This is for the error of a sum or a difference. So our rule is when two quantities are added or subtracted, the absolute in the final result is the sum of the absolute errors in the individual quantity. Now our second point is error of a product or a quotient. Error of a product or a quotient. So let us see. That is our point B, error of a product or quotient. Hence the rule says when two quantities are multiplied or divided, the relative error in the result is the sum of the relative error in the multipliers. Let us see, if z is equals to a into b and z is equals to a upon b, then the relative relative error in z will be equals to del z upon z, which is equals to del a upon a plus del b upon b. Our third point is error in case of a measured quantity to a power. Error in case of a measured quantity to a power. If we take z the power a to power k, then del z upon z will be equals to k into del a upon a. If is the relative error in a physical quantity raised to power k is k times the relative error in the individual quantity. Here we have seen a to power k, which is an individual quantity with multiplied. Okay, these are the combination of errors. Now our next topic is rounding off. What is rounding off? Rounding off of the uncertain digits. Rounding off uncertain. What is rounding off? So, the result of computation with approximate numbers which contain more than one uncertain digit should be rounded off. Now, if we take 2.746, then the number we proceeded which is greater than 5. So, this will be rounded off as a 2.75. This value will be raised by 1 if the number is greater than 5. If we are taking 243, the number is less than 5, so we can proceed as 2.374. The rule by convention is that the preceding digit is raised by 1 if insignificant digit to be dropped is more than 5 and is left unchanged if the letter is less than 5. If it is 5 is greater than, this digit will be changed. If 5 is less than, this will be remain unchanged. Next, if the preceding digit is even, the insignificant digit is simply dropped, and if it is odd, the preceding digit raised by 1. If 2.745, then we round off this digit as 2.74, and if 2.735, then the digit will be 2.74. Like this. This is our rounding off. Here one example is also given. The exact number that appear in the formula like 2 pi in t is equals to 2 pi L upon G. Now the significant number of a pi will be 3.1415926 and so on, but we are considering as 3.14 with a limited number of significant digit figures as required in the specific cases. This is our rounding off of uncertain digits.